Alrighty, so we are doing 27 and stay. I gotta save this later. Okay, so we're doing 27, CS27, and we are finally at week 5, and we're going to talk about linked lists. We're going to talk about linked lists this week, the next week, and the week after that. So first we're going to talk about the basic linked lists, then we're going to talk about a circular list, then we're going to talk about this double-linked, double-ended linked list. Okay? So, linked list is the topic of this week. Okay, so what is a linked list? It's a list of objects that are connected with each other, right? So usually you start with one object that points to another object which has in it a variable of its own type. So let's say you have a class link. The variable in the class that is of link type will be called next, and that will be set equal to some other one, which also will have some other variable next, which is going to be set equal to something other one. So in this way, you're just basically linking up all these different links. Okay, you're going to have a couple of things in there. You're going to have a next. Well, I guess I'll just show you. I'll show you when I get to it. So the advantage of linked lists is, remember how we had to shift a whole bunch of things in arrays, right? If you delete in the beginning from the first element in the array, you have to shift all the other ones to the left. If it's somewhere in the middle, you have to shift all the ones to the right of it to the left. If you were to insert in the first place, you have to shift all the other ones to the right. Well, that takes a lot of time, especially if you're not talking about just a basic array of integers, but maybe it's like some monster objects of data. So shifting these things around in memory takes a long time. But that is where linked lists come in, because if you have a linked list and you want to insert in the beginning, all you have to do is you have to tell it, okay, we're going to insert a new link. The new link is going to point to the first thing, and then as soon as I tell the new link to point to the first thing on the linked list, then the marker which keeps track of where the link starts points to the first link. So basically all I have to do is create one new connection, repoint this thing to the new inserted link that I inserted, and that's it. So two simple things, and then I'm done with inserting. If I wanted to delete something, let's say I want to delete this particular one, all I'm going to do is I'm going to tell this one here, instead of pointing to this, point to the next one, and link is gone. That's it. You don't have to worry about memory leaks. If you're doing this kind of a stuff in C++, you have to actually delete the links, because C++ does not have automatic, garbage collection like Java. Java has something called literally a Java garbage collector. And if you have a bunch of objects that haven't been used and they're just floating around in memory, the Java virtual machine or the garbage collector goes in there and just wipes it all out. And if this was a C++, all these objects that you created but you forgot to delete, they're just floating around in memory. They still belong to the program. And if you ever create more and more links, that takes up more and more memory, which belongs to the program. And then eventually the program ends up sucking up all your system memory. The computer crashes, or the operating system, stops the program somehow. Okay? So the advantages of linked lists are quick insertion, quick deletion. Okay, but it's not perfect for everything. Okay, the disadvantage of a linked list is if you have, let's say, 10,000 things in an array of things, right? If you wanted to go to a specific element, let's say I want to go to number 9,999, I just put the index, and the program jumps straight to that particular element. Okay, I can't do that to a linked list. The only way for me to, let's say in this particular case, I have 4 links, right? The only way for me to get to the last one is to start all the way to at the beginning, and then go to the next one, go to the next one, go to the next one, go to the next one. Okay, so actually searching through linked lists, jumping to a specific link is slower than arrays. So, okay. And you can, similarly to arrays, you can create lists of whatever you want, right? It doesn't have to be a list of integers. In fact, by definition, these links are going to be objects. So you basically make up your own data, okay? Call it an apple or whatever. Instead of a link, you can make whatever objects you want. Okay, so I'm going to go in there and just go through this thing real quick. All right, so this is your chapter from LaFour. All right, the best data structure book ever. So talks about linked lists, and it'll mention basically these different things that I told you about. And I'm just going to zoom in on this a little bit. Okay, so what is this going to be? Well, we're going to have some kind of a class called link, which is going to be for each of these different things, right? What is going to be in that class? Well, he has some kind of an integer for an integer data, and then some kind of a double for a double data. And then you have a link next. So notice the link is the same as your class name. So you're creating a variable called next, which is of the type of the class itself. Okay? In other words, this thing is going to be equal to other links. Okay? So if this is my first link, right? Let's say this is my link here, right? Then next is going to be equal to the one after it. And then the one after it is also going to have its own variable link next, and next for the next one is going to be equal to this one. And then the one for this one is going to be equal to the last one. When you get all the way at the end and there's no other links, then the last one is going to be equal to no. Okay, so when you get to the end of the linked list, or this is just one type of a list, right? This is just a basic list. Later on, we're going to do like double-ended, double-linked, all kinds of different ways. Circular list. If you have a circular list, the last thing doesn't have to be no. Then you can just basically tell the last link to go and repoint to the first thing. So it's basically, it doesn't really have a beginning and an end. They're just kind of linked all with each other. Okay, so we'll look at that too. All right, so this is something that Java does easier than C++. In C++, you have to use pointers to create these linked lists. Java doesn't have pointers at all, so that's how you do it. Okay, you cannot do this kind of a magic with C++, so it's just the syntax that Java uses cannot be applied to C++, just so you know. And that's what it talks about here, how Java uses references, does not use pointers like C++. And that there is no real position, right? So there's no position, there's no way for you to tell it, go to link number 5. You're going to have to start at the first link and jump through all these different links which have relationships to each other, right? One is connected to the next one is connected to the next one, right? You can't really talk about position. It's really just in terms of relationships. Okay, and he's got some workshop applets in there. I'll skip this stuff. Okay, so simple linked list. This is your class link, right? And just like any other class, we need a constructor, right? What is the constructor going to do? Well, it's going to allow the user to enter some kind of a data for these links. If you want to simplify it, you can just get rid of the integer data and just leave it as, get rid of the double data, just leave it as an integer data. It's still a linked list. It's going to have one less variable in it. Okay, and you want to be able to show the link, right? So all we have in this is we have, for now, we have a constructor and we have a way for us to show the link, right? Which is going to show us my integer and my double variables. Okay, so that's easy enough. We haven't done anything. And now this thing, and it probably would make sense to, but notice how the variables here are public. Okay, in fact, I think that's changed from what the original thing showed. I don't know. Oh yeah, they're public. Thanks, Andy. All right, so yeah, these are public, and the reason we make these public is because we want to have access to the links directly. Okay, if we can also make them private, but then we're going to have to go and create methods so that we can change the links. So just for simplicity's sake, we're kind of breaking the rule for Java that tells you that all variables should be private if you can, you know. That's why we're using public. Okay?
Like static?
Huh?
Static.
Static. Well, static will then make it so that the data for each of these links is shared by all the links. So it won't make sense to have a static. If you have a static variable, whatever that variable is equal for one of the links, that's what it's equal to all the links. So you don't want static.
So public, what's the difference here?
Between static and not static?
Yeah, public.
Okay, so there's different. I actually went through this. Oh, let me see if I can find the email. All right, I'll tell you. So public means that this can be used by anything, right? So any class anywhere in the world can use your public data, right? That's actually how they describe it, the Oracle, the webpage. They call it this: the public is accessible to the whole world, right? If you have private is not accessible by anything else except public methods which belong to the class itself. So if I go in there and you know how the book, or not this book, but a lot of books say public class blah blah blah. If I make a private class something, that class will not be accessible by anything. It's just basically kind of useless. So top level class, which is the one that's all the way on the top in the file that needs to be accessed, should not be private. Okay, there's also protected. There's also no modifier, right? And it basically that changes the accessibility. So for one, you can access it from things that are in the same folder. For other one, you can access it from things that are from another folder. There's different access modifiers. So there's public, there's private, there's protected, and there's no modifier, right? The no modifier, if you don't put anything, that cannot be accessed by another program in another folder that does not. That's basically it, right? If you have protected, then protected can be accessed by another Java file in another folder, but only if that Java file inherits this class. So when you create a class let's say you're creating a Java class and you want that class to inherit the properties of some existing class, you would say some class extends some other class name. So if a class extends, then you can use the protected variables, right? So there's different things, and you can just Google Java public private, and you can see that in the actual Oracle webpage they'll have some examples in there. Okay, if you need more examples, I'll be happy to show you, because I emailed the student exactly that same answer for this question. But for us, so we're using this as public because we want to just easily access the links and change them without having to write methods. That's why when I was looking at this thing, I was kind of thinking, well, hold on, where are the other methods? They have one for constructor, they have one to show the link, but they don't have anything to change the data or show the data. And that's because the data is set up as public, which means we're going to be able to see it from anywhere without making methods. Okay, so this is just the basic link, right? So this is the link. So this is what's going to be the entire content of the links. Okay, now where they get linked together is with this class called link list. Okay, the class is called link list, and what does that class have? Well, it has a variable called link first. Okay, private link first. Okay, this is also a link, right? So this is basically the same thing as this right here, right? It's just another link. So what is this? So the purpose of link next inside of your links is so that each link can point to the next link. The purpose of this link here in your link list is to point at the first link in the chain of links. Okay, that's it. Whenever you create a new link list, right, that's your constructor, you're going to say that first is equal to no. So if first is equal to no, there's no links in the link list. And this is how you check to see if it's empty, right? And in here, they have a picture that shows you how to insert first, right? So you have your pointer first, which is basically this thing here, right? This is your first link, which initially would point to to no. But let's suppose you have you have already inserted a whole bunch of links. You have something like this, okay? So this is my first, which points to this link, which has a number 42 in it. Then this thing points to the next one, which has the number 7 in it, etc., etc. The last one doesn't point to anything. That one's equal to no. Okay? So now what we're going to do is we're going to try to insert a new link where this one is. Okay? So all we have to do is you have to do a couple of steps, and the order of these things matters. Okay? And I highly encourage you to do this on paper. Okay? For me, it really helped. So whenever you're going to try to do something, you're going to be like, okay, so first of all, why do you think this has to be first and this has to be second? So basically, the way I know which link is this is by this one, by looking at the content of this one, right? So basically, what I have to tell it initially, I have to tell it, okay, this here, this next on this new link is equal to whatever this one was equal to in here. So that's the first step. So the first step is basically I point this to this one. Okay? I point this new link to the link that has 42 in it. Okay? And the next step after that, so at this point, both of these are going to point to the same place. I would have, as soon as I'm done with step 1, this new link points to this one, and then the link called first also points to the first one. So that's the first. This is right immediately after the first step. And then the next step is step 2. The step 2, I'm going to say, okay, well then this link here, which is called first, is equal to the new link. So that's why this is my first step, connect to this one. Second step, connect to that one. And that's it. Okay, it might look very easy, but really you got to take your time to go through it step by step. Draw this stuff on pictures if you have to, on paper, to help you understand. I had to. Okay? So that's basically how the insert works, and these are the different steps, right? So I said the first step right here was tell this new link that it's equal to whatever the content of the first link was equal to. That is this piece right here. Right here. So first, I create a new link. I give the values for the link. So I have created a new link. I have given it a value of 33. Okay? As soon as I give that value of 33, then I say new link next is equal to first. New link next is this right here. Right? And I'm making this thing equal to whatever this here is pointing to. Okay? So basically, in other words, next now points to this. Okay? That is this line. And then I say, after that, I say first is equal to new link. Okay, so that means now this one here is equal to this link. And that's all there is. That's the entire insert. But the order of things matters. Okay, if you did this first and then you did this one, it's not going to work. It's not going to create you a link list. And you can easily see that as if you're trying to show the different links, and it doesn't show you the links in the correct order, you're going to see that, okay, it's not working. Okay? Delete first. Okay, so how does the delete first work? There's a picture in there, right? So this is my before deletion, right? So before deletion, we have 27, 94, 6, and 33, and that first link points to the 27. Well, deleting just means I'm going to tell this one here that it to be equal to whatever the next of the link with 27 is. So in other words, this here is equal to whatever this is in the next one. And the effect of that is basically just this points now to the next thing. That's it. What happens to this? The link 27, well, it floats around in memory for a little while, and the Java garbage collector just wipes it out. It, recovers the memory so that you can use it for other things. Okay? So there's also a display list, and the display list is what you do is you create a link called current, right? Current is equal to the first link on your link list, right? So current is equal to this one, right? Or whatever, or this one, okay? So now current is equal to this one, and what I'm going to say is while current is not equal to null. So I'm going to make current equal to basically the next one, the next one, the next one, the next one, and eventually current is going to be equal to the null all the way at the end. Okay, when that happens, my loop stops. Okay, so this is how I do this thing. I tell her, okay, start the current at the first, while the current is not equal to null, display the link, right? And what is the display link? What was the display link? It was in the actual link itself. It just shows the data of the link, right? So show the data of the link, and then tell current that it's equal to current next. Okay, so my current, so initially I said current is equal to first. Well, what is first equal to? My first is actually equal to this link right here for the link 27. Okay, but remember that the link 27 has a variable called next, right? And that's why we had next here. Let me go back up. This next, right? So if I say current that next, I'm accessing this variable next. That's why it's public, right? The reason why we made this thing public is so that I can do this business right here. Where is it? Next one. So that I can do this right here. So I'm telling it you are equal to the thing that's after this one now. So you just move it one down, one down, one down. Does that make sense?
That makes sense until Java cleans it up. Because once the garbage collection happens, now you remove the link.
Well, no, we're not talking about removing here. This is just displaying the list. Right? So you have a link, a set of links, and you're telling it, okay, we're going to start at the first one. We're going to start current at the first one, and we're going to move the current one down, right? We're going to move the current one down until the current becomes equal to null. When the current becomes equal to null, we got to the end of the linked list. And that's it. Then you just show every link, and you're done. Okay? So the actual things that, it might take some time for you to wrap your mind around this thing, because you have an object, and inside of that object there's a variable of its own kind, which is equal to some other object. So that's why I'm saying write it on paper, draw some pictures, and see how it works. Okay? It really, I have some of this stuff, and I'll show it to you. Okay? So that's basically how the current works. All right? Yeah, so this is so let's say this is my, and they have another picture in here. LaFour has another picture. Let's say this is my current here, right? This is my current link. This is before current is equal to current next. As soon as I say current is equal to current next, so basically there is a link called current which is equal to this link right here. Okay? As soon as I say current is equal to current next, I'm basically telling it you are equal to this right here, and which itself is equal to this next link right here. Okay? For me, it helps if you actually label them like link 1, link 2, link 3, link 4, so that you can know which one is what. Okay? And that's pretty much it. And then the whole thing combined into one program. Link lists, right? So this is the whole program. So you have your link. This is the link, right? Then you have your link list. This is your private link first, right? Then you can make, this is your constructor, which makes the first equal to nothing, to null, checking to see if the list is empty, inserting a first link, deleting the first link, displaying the whole list, and I also have a delete a link in there, okay? And for deleting a link, I'm going to go look at some of these pictures that I have. Did we look at a delete a link? Did it have a delete a link?
No, we delete first.
We did a delete first. Yeah, delete first is kind of an easier one. Okay? Because to delete first, you're just telling it first is equal to first next. Okay, so let's move down. Let's see if it actually covers delete a link somewhere. So this is insert, delete first, display list. Okay, so that's that. Now deleting a specific link, and that's the program link list 2. Let me see if there's a picture in there to illustrate this thing. All right, so here's how it goes. So what you need to do is you need to have two different variables of the link kind. Okay, so you're trying to delete this link that's with 98, which is going to be your current, right? So basically, let's say I'm looking to delete the link 98, right? So I'm going to use my show list algorithm where I basically do current is equal to current next, right? So I tell it while current is not equal to null, keep going, right? So it starts at the beginning, goes to this one, checks to, let's say I'm looking for the number 98, right? Current is equal to first initially, right? Then I say, all right, is current dot data equal to 17? I mean 98? No. Okay, current is equal to current next. Okay, so now current, and by the way, previous is one behind the current, always. Okay? This is actually a little bit more involved than the other ones, and this is where I recommend you drawing these pictures, and I have some pictures drawn for you to see. It might be too much, but I'll show you. Okay, so I started at the beginning, current is equal to first, right? And first is actually equal to that first link, right? So I say, is current dot data equal to 98? No, it's equal to 17. Okay, then I tell, okay, current is equal to current next. So now current is equal to this link. Is current dot data equal to 98? No, it isn't. Go one down, right? And keep in mind that the previous link is one behind the current, always. That's how it works. Okay? Then I go to the next one. So I say, all right, well, it's not equal to 98, so current is equal to current dot next, goes to the next one. Okay, is current dot data equal to 98? Yes, it is. Okay, now I got the 98. I'm looking to delete the link that has 98 in it. Okay, so that means at that point, current is equal to this link, and the previous is equal to the link before. Okay, the reason I need to have previous is because there's no way for me to go backwards in the list. This is a single link list, which means that we can only go forward. We can start at the beginning and we can move forward until we get to the end. I can't jump back at any point. We could do that when we create double linked lists, but we're not there yet, okay? So that's the reason why I have a previous, so that I can keep track of the previous link before the current, okay? And then the only thing that I have to do is I have to tell it, okay, well, previous is equal to current dot next, right? So in other words, this is my current, and current dot next is actually equal to the next link after. So if I just simply say previous is equal to current dot next, that means I have now repointed my previous to this. Current is still going to keep the information for my link of 98, so I can maybe show it to you or whatever. But that's it. At this point, as soon as I say previous is equal to current dot next, I have now created this deletion. Or I have to remove the link, and then later on, Java garbage collector is going to clean up the garbage. Okay? And that is basically, well, both of these are, the find and delete. They kind of, do the same thing. So the delete takes advantage of finding a link, and then to delete, you just tell it current or previous is equal to current dot next. That's the actual deletion. Okay, so let's have a look. So if current is equal to first first is equal to first next. Okay, otherwise previous dot next. So this is to make them move one after each other. So current is equal to first. And double-ended lists, we're not going to go that. We're going to look at that thing later. But basically, what's a double-ended list? Well, you have some kind of a linked list link if you want to. Or basically, you have two pointers. You have one link called first, which is equal to the first link. You have another link called last, which is equal to the last thing on the element. Right? That just allows you to know if you're in the beginning or you're at the end, but you can still figure out if you're at the end by checking if it's equal to no. Okay, so what I'm going to do is I'm going to look at this little picture here. So I have a couple of things in here. I have the linked list insert, linked list delete, and a couple of these sample programs that I'm showing you right now. Try not to copy paste these, write them from scratch, get it to work, right? You don't benefit from just copy pasting things. I wrote them down myself. I didn't copy paste them. What we're going to do is we're going to look at insert. Is that what it is? So insert. So the insert link, I think, is pretty straightforward. Right, so I'm not going to show too. Yeah, I have a whole bunch of pictures in there. Right, if you want to look at them in detail, I pretty much show what happens every step of the way. Right, so what helped me was to kind of stack all these different things next to each other. Right, so this is my linked list app. In the beginning, I create a linked list. The list is equal to new linked list. Right, as soon as that happens, basically I have this situation. Right, so I have linked list. The list is equal to new list. So that's basically I have a link where the first is equal to no. Okay, so I haven't added any other links. Okay, then I start adding links. Insert first. Okay, insert first. Right, calls this method. This is the data. The next for the first link is equal to no, and I even have where do I have them? The pictures in there. Where's this thing? Okay, so it might get a little more confusing for you, so I'm not going to go into too much detail with this, but basically, if you want to trace how your program works every step of the way, I have these pictures in here for you. And this one here is how we insert a link. So we have a first link, and then we're trying to insert a new link, and I have basically just different pictures of the steps that that this undertakes and what parts of the code that it uses. So I'll let you read that at your own time. I pretty much explained what I wanted to explain to you. This is just like graphical representation of what I said, with which shows you how it works every step of the way. And what I did was, again, what did I do? I started with an empty link. I started with something that doesn't have any links, right? Then I go and I add one link. Okay. Then I go and I add a second link. Okay. So this is in the beginning. Then this is how it works. This is how it looks at the end. Then I add a third link. Right. So it really will help you to understand this if you draw this on paper. Right. I did it in OneNote or whatever I used. It was OneNote. But I think it makes sense to do this on paper. Okay. And I may have overcomplicated this a little bit, but whatever. I like to go in detail, so I recommend you do that too. The next thing is delete. So let's look at the delete business real quick. All right, so I have a bunch of links. All right, so let's say I have delete first. Right, so I have some kind of a temp which is equal to first. First is equal to first next, and then okay, so this is just the purposes to return temp. Okay, so I have these three different links. All right, link 3, link 2, link 1. Link 1 points to no. I'm trying to delete link 3, right? And by all I have to say is I have to say first is equal to first next. So now first moves to the next link. First is now equal to the next link. Okay? Now this one here, this one shows you how to delete a specific link. Okay? I'm not sure which link I'm trying to delete. All right? And this will show you how basically the previous and the current works. Okay? So look at what we have here. We have current, two links. One is called current, the other one is called previous. Both of them are equal to first initially. I keep looking until I find the data that I'm looking for. So delete is going to delete a certain key, a certain integer value or whatever. Okay? So if my current.data is equal to the key, then I want to delete it. Okay? So basically this is going to go on until I find the correct link. If it gets to the end, if my current.next gets all the way to the end of the thing, then I just return no. Basically, I couldn't find it. Okay? Otherwise, if we're not at the end of the linked list, previous is equal to current, and then current is equal to current next. So previous assumes the place for the current, and now the current moves one down. Okay? This one here is basically how do we handle deletion. So if you happen to be deleting the first link, if we found this data to be at the first, so if current is equal to first, then you just tell it, okay, first is equal to first next. So that's deleting the first link. Okay. Otherwise, I have to tell previous.next is equal to current.next. Okay, and that is the little picture that was in there. Where is this? That's what's happening here. So you have previous.next. Previous.next is equal to current.next. In other words, now this link with the number 44 points directly to the link 73. Okay? And that's it. That's basically linked lists. Okay? It seems easy on the surface. It's not that hard at all, as long as you can sink your mind in it. But for me, again, it helps drawing these things on paper. And so that's what we have to do for this week.
Do we fill unique IDs, or do you have to also have duplicated IDs?
You don't have to worry about duplicated IDs. Yeah, if you want to delete, if you have duplicates, just delete the first one you find. Or you can keep deleting until delete all of them. Yeah.
So you get to know, and we have to traverse the whole
Yeah.
linked
Mm-hmm.
list, right?
Yeah. You could it should still work the same. Yeah, but no, you don't have to worry about duplicates. Let's just assume they're all unique
We just
values.
make your delete function just take long because you'd always have to go from the beginning to the end.
Well, you might think of a way to do it so that when you delete a link, you restart from where you delete it instead of at the beginning. But yeah, you could also start from the beginning.
But either way, you still have to traverse the entire list, as opposed to if you just have unique IDs, you stop when you find it.
Yeah.
And you leave.
Yeah. Okay, so assignment 7 is not a very difficult one. So what I have for you is basically, well, let's see what it is first of all. Yeah, you're going to test that first linked list program, listing 5.1, get it to work. Again, don't just copy paste it, even though I give it as an example. Then use the display list method, which shows you how to traverse the list, how to jump through the different links, so that you can figure out the sum of all the data inside of the linked list, so that you can find the link with the smallest value, and to count how many links total are in the linked lists. Okay, and then you have to test all these 3 methods in the main, show that they work, and that's it. So it's really not a very difficult one. Any questions? You don't have to all ask at once. Okay, so that's all there is for this week, assignment 7. And there's more assignments in the back of the text. We're going to do more of those in the coming weeks. We're going to talk about circular lists. Remember, circular lists. We're going to be talking about, oops, wrong class. Oh. Alright, so this was just the regular linked list. Then we're going to talk about a circular list, which does not really have a first to speak of. There's just current. Current could be pointing at any link in the linked list, and it's just a circular list. It doesn't have a beginning and an end. So how would you figure out that you went through the list? Well, you can have some kind of a variable called like number of links, which keeps track of how many links you inserted, and then as you're going through each of these links, maybe you can have a counter that counts how many links you have visited, and if your counter becomes equal to the number of links, you can stop the thing going, in circles. Otherwise, it'll be just a never-ending, circular loop. And then we're going to talk about, after that, week 7, double linked, double ended, linked lists, and we're going to make it a priority queue. So basically what it's going to be is we're going to have the ability to insert in order. We're going to have links that link to back and forward, and we're going to have a pointer that points at the first link and at the last link, so we know which one's the first and the last. Okay? And that's it. That's the plan for the next couple of weeks. Get this done, and I'm going to post some solutions for these stacks and queues soon. Okay? So if you have any questions, come see me in the office hours or email me your questions.